Okay, this video is the solution to homework number 3, lab number 3. And the problem that's given to you is a folded sheet metal. So as soon as you see this, you have to realize that this problem must be done with shell elements, okay? Don't try to do it with solid elements. Of course, many of you will see that this is a surface, but even if I had drawn this thing, even if I had drawn it as a three-dimensional object, you know, the grayish solid part, you should realize that it has to be done with shell. Okay. Now, the bottoms are clamps. The bottom of these bottom edges are clamped, and the top is subjected to a downward displacement of, I believe, 1 millimeter. One thing you have to realize that there are different ways of doing problems like this. So I'm going to do it for you 3 different ways. Any one of them, as long as it is done correctly, or any other method will be acceptable. But I'll do it 3 different ways. That's why the video may be a bit longer than basically solving the problem 3 times, different ways. Now, the other thing is that you have to realize that obviously shell elements are to be used, and there are 2 planes of symmetry. In other words, you can cut it along the length, and you can cut it this way. So the choice is yours. You can actually make 1/4 of this model, or you can make the whole thing and then start cutting it or splitting it with the saw. One other thing, I made it on purpose. The top face has a different thickness than the side faces, the other faces, okay? So let's go ahead and make this thing. So this is approach number 1. I'm going to start doing this thing without extracting the surfaces, okay? So I'm going to directly generate surfaces, and that's obviously going to be a generative shape design. So let me start with the part. Okay. I'm not starting with a product because I'm using a single part. I don't want to get confused. Okay, let me change the background color. So tools, options. Let's see, tools, options. I think visualization, something like that. Just bear with me for a second. Okay, display, okay, display visualization, and let's use the standard color here. Let's move on. On that vertical plane, I will sketch. So I will model the entire thing and then cut, okay? So as I said, you can start with 1/4 and then proceed, or you can model the whole thing and then cut it. I will clean it up in just a second. I'm trying to do something like this. Okay, so left line, control, right line, control the middle axis. I'm going to make it symmetric. Very good. And let's give dimensions here. Yeah, so let's give some dimensions. The distance from here to here is 150 millimeter. These are all inches, 150 mm. Okay, this length, I believe this length is 30 mm. Okay, what else do we have? That radius, this radius is 20 mm. And so is this one, 20 mm. Okay, so I just want to make sure that this was correct. Actually, this should have been 30 mm. This is a recipe for disaster. It's a better idea if you go and change your units so that I don't have to watch behind my back all the time. So let's go ahead and do that. tools, where's that, tools, options, and I'm going to change my length to under parameters and measures, change my units to millimeter. Okay. And there's something that I don't like here, and that is, let's see now, 20, 20, 30, fine. I'm not sure what this thing is. Let's find out what this dimension is. That should also be 30. Yeah, that's why this was not quite, that was not quite green everywhere, 30. But now this is fully constrained. Now, I want to exit this and extrude it to create a surface. So, what is exit? Exit is right here. Okay, you want to extrude this as a surface, but you can't do that thing in part design. So you have to go to generative shape design, in other words, shape right there, see? Shape, generative shape design, and you want to extrude it by 50 millimeters in each direction, so it's a total of 100. Okay, so where's extrude? Extrude is right here. All right, I'm going to do a mirror extend, 50 millimeters in each direction. There we are. Now I want to make a hole on the top. So on the top, I will sketch a circle. And the radius of that circle, according to our drawing, can't remember, 10 millimeters. Okay, so that's going to be 10. So, okay. Exit. And we're going to split that surface with this circle. So here's the saw under operations toolbar where the joint is, saw. This. Read this carefully. It says cutting element is this. Hang in there. Something is not right here. Let's read this thing carefully. Okay, cutting element is that circle. So why is this thing not working? Okay, I see. Let me cancel that for a second. Try it again. So where is this? Split. Read this thing carefully. Element to cut is that face. Cutting element is this circle. There. A couple of comments. The way I have done it does not require join. Okay, we're talking about shells now. The way I've done it does not require a joint, and it's already, think about it as a surface, single surface. So when I mesh it, the entire thing is going to get meshed later on, and material property, when I apply on it, it's going to be applied everywhere and the thickness, okay? But just bear with me for a second. So we're going to split this thing more. So we're going to split it with this plane. Cancel. I'm not reading my dialog boxes. So we go split. Element to cut is that surface. Cutting element is this. We'll keep that face, that side. Okay. Read it, split it again. Read it carefully. Element to cut is that surface. Cutting element is this. And because I did a mirror extend, obviously it's the right side. Now we're going to hide these sketches. This sketch is going to come and bite me later on, so I'm going to hide it. Okay, there we are. And so is the sketch, hide it. Because sometimes I inadvertently may try to put the displacement and the restraint on these sketches, and it's not going to take it. Okay, so let's apply material to this thing. I believe it was steel. Apply material, metal, steel on that part. We say okay. And we are pretty much done here. So we're going to go to generative structure analysis. CATIA does not see a solid object, so it's your responsibility to mesh this thing, just like you mesh beams, okay, yourself. Obviously, we are doing a static analysis, so that's good, static analysis. And here is the it's called octave triangle mesher, or call it shell mesh. That face, the entire thing is going to get meshed because of the way I constructed it. The second method that I'm going to show you, in order for this to happen, you have to join these surfaces, but not here. You're not going to gain anything by joining or not joining, okay? So this is parabolic. In the absence of any information, use whatever you want. On the test general, we ask you to do linear with default sizes unless specifically asked for something else. So I'll just use parabolic here. Good. The mesh is there if you want to look at it. Right-click mesh visualization. The mesh is already there. This is just displaying it, okay? Don't get the impression that if you don't see the mesh on the screen, you cannot, the mesh is not there. So let me change the rendering back to where it was. Or actually deactivate this, because without going on the screen, there's nothing you can do. Okay, now how about the properties? Now, if I apply a property on this, because of the way I constructed it, everything is going to be picked. So this is the top. Right now, I'm going to say, I don't know, what did I have here? I had the top is 2 millimeter, everything else is 4. So right now, let me make it 4 millimeter. That means everything is 4 mm. But I want the top, this piece, to be 2 millimeters. So what I need to do is go there, right click, local mesh property, local 2D property, click on that top and change that to 2 millimeters. So right now, the top that I change is 2, but everything else is 4. Okay, good. So the bottom of this thing is clamped. All right, and these are planes of symmetry. So let's start with the user-defined restraint. Uncheck everything so that you don't get confused. So if you look at this edge and that edge and that edge, these all lie in the YZ plane of symmetry. Just look at the coordinate system, YZ. If it's YZ, does not move in X. And rotations are opposite. Very important. Okay, now let's do the other side. So another user-defined restraint. This other edge lies in the XZ plane of symmetry. As soon as you say XZ plane of symmetry, no displacement is in Y, rotations opposite. This is symmetry constraint. It is a notice that these things were because of planes of symmetry. Now we want to take that top edge and push it down by 1 millimeter. So I do another one so that I don't get confused when I try to debug these things. I take that particular edge, zoom in, this particular edge, and in the direction Z, I make it 0 because I want to be able to change it. Enforce displacement. On this last one, it's a good idea to give these things meaningful names so that I know which one is which. I should have called this thing pushing down, okay, but I didn't. Make sure you don't get confused. Minus 1 millimeter, and say okay. Good, so we have a load here, which was the one that I enforced, and hopefully we didn't forget anything. Let's go ahead and run it. Excellent. Let's look at the deflection. Nothing magic is going to happen. You expect this thing to happen with displacement. If you like color stuff, color means nothing. At least it looks the way it's supposed to be. Now you're also asked to find the force needed to cause this displacement, this deformation. You put the cursor there, right click, and create resultant sensor, reaction sensor. Now it says where, so you have two choices. You can select the clamp, or you can select the thing that you used to push down. And update, and do not forget that this number has to be multiplied by 4. The force needed to cause this deformation on all four sides, we're just modeling one of them, is 4 times this. Okay? So we say okay, and that takes care of the first approach. I'm going to do a second approach now. Let's get rid of this. Okay, let me start with the part file. And you might wonder, well, you might say that this is, I don't know, more complicated or more tedious, then why should I do it like that? You don't have to do it like this. So on that face, I will sketch the same thing that I had before. So let me quickly do that. Okay, let's clean it up. So left line, control, right line, control the middle axis. We make it symmetric. Okay. And let's give some dimensions here. So dimension from there to there is 150. This is 30. That's okay, don't worry about it. This is also 30. 30. Okay, good. So this is 10, sorry, no. Actually 20. This radius is 20, and this radius is 20. Okay. Now these two have to be tangent to each other. These two have to be tangent to each other. So that line, let's do this. Thank you. This curve control that line, we make them tangent to each other. Good. Exit. Now I'm going to create a solid object out of that because my plan is to extract the surfaces, okay? So let me go ahead and actually go to part design. To make a solid object, I have to go to part design. I'm going to pad this thing by 50 millimeters in this direction. Yeah, I see. There's something I forgot to do. Let's go back to that sketch. In order to pad this thing in 3D, I would like to make it closed curve. In other words, it can be done like this, but I don't want to. From here to here, yeah. That makes it a closed curve now. Exit, pad it, in both directions by 50 millimeters. Excellent. Now on the top, I will sketch a circle. I think the radius is 10. Radius is 10 millimeter. Exit. Make a pocket. Make a pocket all the way through. Good. So, and apply material to it. So, apply material. We're going to make it out of steel. Metal, steel. Say okay. All right. Now I want to let's also split it. Let's also cut it. So where's the cut here? Look for the saw. Look for a saw. I mean, after a while, you know exactly where these things are, right? Right there. Saw. split. So we're going to split it with this side. Doesn't matter which side we keep, and then split it with the other one. Excellent. So now we're going to go to generative, because to extract surfaces, you have to go to the generative shape design and look for the icon which is extract. I believe extract is probably in this operations toolbar. Let's find out. Yeah, if you look at the, here's join, here's a split, look at the third one from the left, and this says extract. You can do this thing 3 times, or if you click on this bag, you can do it simultaneously. This and that and that. Otherwise, you have to do it 3 times. That's fine. Okay, I no longer need this. I'm going to hide this. There we are. Now, notice that I'm not, I'm not suggesting that you do it like that, but it's entirely up to you. These two have the same thicknesses, for example. Okay. Well, first of all, you can join all of these and go the same route that we had before. That's one way. Okay. Let me actually not do it like that. Let me not do it. Let me not join. Just join these two. Okay. So join this and that and say okay. Good. Notice that that kind of line disappeared. It's still there. It's the surface. These are 2 separate pieces, but they're joined together. Now, let's go to the generative structure analysis just like before. What happens? CATIA immediately sees a solid object in hiding because I hid it. You see, I hid it. If you go to here, you see the guy is hiding there. That's why CATIA saw it and immediately meshed it. Well, I don't want that. So I'm going to go to here, nodes and element, delete this. And there is a 3D property that was automatically created and delete this. Very good. Now I have to mesh myself. Okay, so CATIA saw a 3-dimensional object in hiding, and it went and immediately meshed it. You can see that it was there. So I have to do 2 things. You have to delete the 3D. You have to delete the what is that? The mesh, the 3-dimensional element. You have to delete this, and you have to delete the 3D property. Delete. Okay, very good. Now we have to mesh these things ourselves manually. So I'm going to click on this shell element, select the top. So it's going to mesh it with element.size. And I'm going to put properties on it. So this is 2D property on this top surface, which is 4 millimeters. I think it was 4, which one was what? I think it was, can't remember. Just 1 second. Homework. This was homework 3. It was 2 millimeters. Okay, 2 millimeters on the top. So that is 2 millimeters. Good. And it's converted to inches. That's fine. And then I'm going to mesh the side, and it's going to get meshed at the same time because I joined these 2 pieces. And I'm going to put a thickness 4 millimeter here. 4 millimeters. Okay. The bottom is clamped. This bottom is clamped. Okay. These 2 edges. Let's see which 2 edges. Let's see for a second. This edge and that edge and that edge, all 3 of them actually, all 3 of them lie in the YZ plane. They don't move in X, rotations exactly opposite. Okay, now this other one, let me uncheck all of these. so that we don't make a mistake. This edge lies in the xz plane. It does not move in y. Rotation is exactly the opposite. Very good. And finally, we want to push this edge down. So let me apply a zero displacement in the direction z. Nothing else. This in the direction z. And I'm going to change that. Change that last displacement that I created, restraint that I created, and I changed that to this last one. I believe going down by -1 millimeter. -1 millimeter. Yeah, that's pretty much it. Now, if we run this thing, it's going to bomb out because there's a seam here. So the way we did it in class, the fastest way of doing it, create a connection between, for example, this face, and for the second component, that face, okay? And this, I'm going to declare it as fastened. So let's go to fasten connection on the connection property. Okay, you can see that in the tree has been created. Your connection has been created in the tree. I can select it from here, or I can select it from the screen. It doesn't matter. I do it right there. It puts a fastener sign there. It has nothing to do with fastener. It means that they're fully bonded. They're perfectly welded, whatever you want to call it. And this is it. So let's go ahead and run it. And it'll be fine. So just like what you expect, it's going to bend down. I mean, the numbers are here if you want to look at them. Material shading. There we are. Okay, if you look at the von Mises stress, you can look at the von Mises stress. Okay. Now notice that here there is a stress concentration, and the reason is that these thicknesses are different. So it should not surprise you that you have an abrupt stress distribution, stress discontinuity across that line. Now, of course, you have to be very careful to take these for granted. Around that seam, things are very complicated. All right, so I've done this